A second. Yeah. So once again, a very good afternoon to all of you. So we are discussing about the Amines lesson from yesterday, right? So yesterday we have covered the nomenclature, structure, and classification of amines. Then we have discussed about the very important preparations of amines. And after that, at last, we have discussed the physical properties of amines, right? So today we are entering into the chemical properties of amines. So here some around 7 to 8 chemical reactions of amines. Okay. So the very first reaction is acylation reaction. So amines on acylation will form amides. Okay. So the acylating reagents are acid chloride, anhydride, and ester. Okay. So this is the general mechanism conversion. Amine will be converted to amide on doing acylation. So what is meant by acylation, or what is the formula for acyl group? So the formula for acyl group is CH3 C double bond O. Okay. So this is the acyl group. So let me take an amine. Let me take an amine, ethane amine. So I have taken ethane amine. Okay. So ethane amine on treatment with acyl chloride will form N-ethyl ethanamide with the removal of HCl. So how does this happen? So the hydrogen from amine and the Cl from acyl chloride is coming out as HCl, and you have to connect this nitrogen with carbon. Okay, connect the nitrogen and carbon, you will get the product. Okay, so who is this? CH3CO group is the acyl group. So that acyl group is going and getting substituted in place of hydrogen in amine. Okay, so this is the reaction with acyl chloride. The next is, here pyridine is used as a base. So pyridine is used as a base. I mean, it is used to remove the HCl from this compounds. Okay. So let me take one more compound. Let me take benzenamine. C6H5NH2 is called as benzenamine. So what will happen if benzenamine is treated with anhydride? Let me take one anhydride, acetic anhydride. So here what happens? The hydrogen from amine, OCOCH3 from acetic anhydride is removed as acetic acid. Okay. So the CH3CO part is going and getting substituted in place of hydrogen in amine. Okay. So an amide linkage is formed in the product. So that's why amines on doing acylation, we are getting amides. All right. So whatever might be the compound, you can take ester also. What is the formula for ester? R C double bond O O R. This is a formula for ester, right? So this will be the acyl part, and you have to remove the O R along with the hydrogen. Okay. So we will remove the alcohol. We will remove the alcohol from if we are using the ester with amines. Okay. Can you able to understand, students? Can you all able to understand the acylation reaction of amines? So you can do this reaction only with primary amine and secondary amine. Okay. So the tertiary amines will not have the hydrogen in it. So the removal of hydrogen is not possible, and the acylation cannot be done in case of tertiary amines. All right. Shall I go for the next reaction? Shall we go for the next? Is it clear to all of you? Say yes or no. Okay, let me go for benzoylation reaction. So here in case of benzoylation, I have to use benzoyl chloride with amine. Okay. So the only difference between acylation and benzoylation is there we have to use acyl containing compounds, and here we have to use benzoyl containing. Benzoyl means C6H5CO. Okay, C6H5CO. So the hydrogen from amine and chlorine from benzoyl chloride will come out as HCl, and as usual, we have to connect the nitrogen with carbon. We have to connect the nitrogen NH with CO to get the product, the amide product, and the HCl will be removed. Okay. So if you are doing the reaction with benzoyl chloride, then it is called as benzoylation. All right. All right for everyone. So let's go for the third reaction. The third reaction is called as carbyl-amine reaction. So what is this? This is one of the very important reaction. Okay. So here we have to take an amine. Okay. We have to take an amine. It should be the primary aliphatic amine or primary aromatic amine. Okay. Aliphatic amine and aromatic amine. Any amine you can take. And treat it with CHCl3, which is called as chloroform. And you have to add one more reagent that is called as potassium hydroxide. Okay. So you have to put all these three components and you have to heat it. If you are heating it, you will get one compound which is RNC, which is called as isocyanide. Okay. And the other byproducts are KCl and water. Got it? So this isocyanide, CN means cyanide, NC means isocyanide. So this isocyanide will give a foul smell. Okay. So foul smell means a bad smell, the rotten egg or rotten fish kind of smell. Okay. So just by observing the smell, we can say that the amine that we have taken is a primary aliphatic or primary aromatic amine. Okay. So basically this reaction is used as a test for amine. Okay. And the name of the test is called as isocyanide test. Okay. It is used as a test for primary amines only, not for secondary or for tertiary. Only if you are taking a primary amine in your container, you will get the foul smell with the formation of this RNC, which is isocyanide. Okay. The secondary amine or tertiary amine will not produce the foul smell and they will not form the isocyanide. All right. One of the very important reaction you should know. Got it? The reactants and products. Three reactants we are taking and there is a formation of three products and all the compounds are very important. So can you understand this? Shall we go for the fourth reaction, my dear students? Say yes or no. Shall we go for the fourth reaction? Shall we go for the fourth reaction? Okay. Thank you so much, Madhukar Reddy, for your response. So let me go ahead with the fourth. It is a reaction with nitrous acid. So we all know what is nitrous acid, right? It is the mixture of HNO2 or NaNO2 with HCl. HNO2 or NaNO2 with HCl. So here we are discussing about the reactions of amines. So first I am going to take the aliphatic amine and I am going to do the reaction with nitrous acid. Then after completing that, we will come to the aromatic amine with nitrous acid. Okay. So let us start with aliphatic amine. So RNH2 is the general formula for aliphatic amine. So if it is treated with the nitrous acid mixture, that is HNO2 or NaNO2 with HCl at the very low temperature, that is from 0 to 5 degrees Celsius, the reaction will occur. Okay. So at this particular temperature, the NH2 group will be converted to N2Cl group. Okay. NH2 group will be converted to N2Cl group. That is alkyl diazonium chloride is formed with the reaction of amine with nitrous acid. Okay. And some other byproducts, NaCl and 2H2O. These are the byproducts formed. Now, this alkyl diazonium chloride is unstable. It is unstable. So what happens? It immediately reacts with the water and it forms alcohol and nitrogen and HCl. Okay. So basically the amine is getting converted to alcohol. Amine is getting converted to alcohol. Okay. So the role of nitrous acid is to convert NH2 group to N2Cl group. N2Cl on reaction with water will form alcohol. Okay. So these are the things you have to keep in mind. Okay. You should know the conversion. factors, the reagents that is being used to convert a particular compound to the other compound. The conversion and the reagents are very important. All right. So this is with aliphatic amine. Now let's do the same reaction with aromatic amine. So let me take aniline. Aniline on treatment with nitrous acid at the same temperature. 273 means 0 degrees Celsius, right? 0 degree to 5 degree. 278 means 5 degrees Celsius. At the same temperature, NH2 will be converted to N2Cl. It will be converted to N2Cl. So we are getting a benzene diazonium chloride. So it is an aromatic diazonium chloride. So this compound is stable. Benzene diazonium chloride is a stable compound. Okay. And the byproducts are NaCl and H2O. So benzene diazonium chloride do not form the alcohol because this compound itself is stable. It will stay for long. Okay. So it is stable and the reaction stops here. The name of this reaction is called as diazotization. This reaction has one more name which is called as diazotization. Azo means nitrogen. Okay. Azo means nitrogen. There are N2, right? So it is diazotization. Got it? Conversion of aniline to benzene diazonium chloride is called as diazotization. We will discuss the same reaction in diazonium salt preparation. Okay, the same reaction will be discussed in the diazonium salt preparation in the later part. Okay. So aliphatic amine is forming an unstable diazonium salt, but an aromatic amine is forming a stable diazonium salt. It is stable, not at all temperature. It is stable only at 273 to 278 Kelvin. That is 0 to 5 degrees Celsius. Okay. If you go beyond this or if you go below this, then at those particular temperatures and all, it will not be stable. So temperature is also very important. So in one of the previous year competitive examination in NEET, they have asked this question in a statement-wise manner. Okay. So you should be very, very careful. All right. So we will discuss those questions at last if we have time. Okay. So let me go for the fifth reaction. So I hope this reaction, fourth reaction is clear to all of you. Right? Shall we go for the fifth? Shall we go for the fifth reaction? Students? All of you can able to understand, right? Do you have any doubts in the fourth reaction? Sivamani, Pyali, Vedant, RJK, guys, tell me. Do you all understand? Yes. Very good. So let's go for the fifth. Hinsberg's test or the reaction with aryl sulfonyl chloride. Okay. So first, let me discuss the reaction of primary amine with aryl sulfonyl chloride or the Hinsberg's reagent. Aryl sulfonyl chloride is a Hinsberg's reagent. Okay. Aryl means a benzene sulfonyl chloride. This is the compound. This is the Hinsberg reagent. The name of this reagent is benzene sulfonyl chloride. So this compound on treatment with primary amine, C2H5NH2, what will happen if this compound reacts with primary amine? The HCl will be removed. Okay, and there is a formation of sulfur nitrogen bond. Got it? The name of this compound is N-ethyl benzene sulfonamide. And HCl is removed. So this reaction is similar to the acylation reaction, right? Acylation and benzoylation. So there also we have removed HCl, but there we had C double bond O. And here we are having S double bond O, double bond O. That's all. But the remaining processes are same only. We are removing HCl from it and there is a formation of amide kind of linkage. So that's why it is called as sulfonamide. This is called as sulfonamide. So in this N-ethyl benzene sulfonamide, we have a hydrogen attached to the nitrogen. We have an hydrogen attached to the nitrogen. And that hydrogen is strongly acidic in nature. Okay, because it is attached to the more electronegative atom, right? So it is strongly acidic in nature. So the entire compound has an acidic hydrogen. So if I treat this compound with the base is otherwise called as alkali. Okay. So if I treat this compound with the base, so this compound will go and get dissolved in alkali. So it is soluble in alkali. Okay. The primary amine giving product is soluble in alkali because it has a strongly acidic hydrogen. All right. Now, what will happen if I treat the Hinsberg reagent with secondary amine? So let me take the reagent first and add the secondary amine. The same HCl will be removed and we get a product like this. Now you see, we don't have any hydrogens attached to nitrogen. We don't have any hydrogen attached to nitrogen. So there is no acidic hydrogen in this compound. And because of this, if I put this compound in a base, it will not be soluble. It is insoluble in alkali. Okay. So the primary amine forming compounds are soluble in alkali and the secondary amine giving products are insoluble in alkali. Okay. You know the reasons, right? So here we have an acidic hydrogen, but in the secondary case, we don't have the acidic hydrogen. All right. Then the third is reaction with the tertiary amine. What will happen if a tertiary amine is treated with Hinsberg's reagent? Do you guys have any idea? Let me take an example. NC2H5, C2H5, and C2H5. So this is a tertiary amine, right? So what will happen if Hinsberg reagent is treated with this tertiary amine? Can anyone tell me? Can anyone tell me the name of the product? First of all, tell me whether the reaction will occur or not. Will there be the formation of product? Will there be the formation of product? Guys, come on. Tell me. Just think once and tell me. Will there be any formation of product if tertiary amine is treated with Hinsberg reagent? Give a try. Give a try. Yes or no? The answer is no. The answer is no. There won't be any formation of product. Okay, tertiary amines do not react. Can anyone tell me why it will not lead to the formation of product? Can anyone tell me why it doesn't lead to the formation of product? Because it doesn't have hydrogen. It doesn't have any hydrogens attached to it. Okay, for all the reactions, we are removing the hydrogen part of amine, right? So there is no hydrogen attached to the tertiary amine so that the HCl can be removed. Okay, so the reaction will not occur. Got it? So tertiary amines do not react with the Hinsberg's reagent. Is it clear to all of you? Any doubt from the Hinsberg reagent reactions? Guys, tell me first. Okay, let's go ahead with the sixth reaction, which is called as bromination. So bromination is one of the electrophilic substitution reaction, right? So I'm going to take aniline. Since we are dealing with the amines lesson, I'm going to take the aniline. And aniline is treated with 3 moles of Br2. 3 moles of Br2 in presence of water. So Br2 in presence of water is the electrophilic reagent. Okay, and it will produce Br plus electrophile. Okay, it will produce Br plus electrophile. And aniline is too reactive towards electrophilic substitution reaction. So the product will form immediately. Okay. So the bromine, which is coming out as electrophile, will go and substitute both the ortho opposition and the para position. So because of this, we are getting a tribromo substituted product. Okay, so here it is 1, 2, 3, 4, 5, and 6. So 2, 4, 6, tribromo aniline is formed from this reaction. Okay, since we are using 3 moles of Br2, a tri-substituted product is formed. So, when will I get a monobrominated product? When will I get the monobrominated? Monobrominated means only one bromine substituted product. That is only para product or ortho product. When will I get this? So, we have to follow some other way to form the mono-substituted product. Okay, so let's see that reaction. Monobromination of aniline. So take the aniline, treat it with anhydride. Treat it with anhydride. So what is this? Acetic anhydride. CH3, C double bond O, O, C double bond O, and CH3. So this is the acetic anhydride in presence of pyridine. Okay. So if the aniline is treated with acetic anhydride, the hydrogen and CH3COO, it will go out as acetic acid. Okay, CH3COOH is coming out and the COCH3 is going and getting attached with nitrogen. Okay, so we are getting this compound called acetanilide. Now, why we have converted NH2 group to an amide group like this? For the protection of ortho position. Okay, so now this HNCOCH3 group looks like a bulky group, right? If you compare it with NH2, it is a bulky substituent. So the ortho position will be protected. Okay, the electrophile. If I put the electrophilic reagent, bromine in presence of acetic acid, the Br plus electrophile will generated, right? So that Br plus cannot go and attack the ortho position because we have a bulky substituent. So they will not have, the Br plus will not have any space to go and attack this ortho position. Got it? So it will go and get substituted only in the para position. It will go and get substituted only in the para position, and then on doing the hydrolysis, we get the NH2 back again. So para bromo aniline is formed from this reaction. Okay. To get the para bromo product, you have to protect the ortho site by using acetic anhydride, and then you do the bromination and do the hydrolysis, you will end up with the para bromo aniline product. Okay. Is it clear to all of you? So just remember the steps. Protect the ortho site, do the bromination, and do hydrolysis. That's all. Now let us do the same thing with nitration. So nitration is also one of the electrophilic aromatic substitution. So take aniline and you have to treat this aniline with the nitrating mixture, right? The nitrating mixture is the concentrated sulfuric acid and concentrated nitric acid. And from this nitrating mixture, we will get NO2 plus electrophile. NO2 plus as the electrophile. So this electrophile is going and substituting the ortho position, meta position, and para position. All three types of anilines are formed from this nitration. And also, if you look into the percentage of each component, ortho is formed at 2% and meta 47, para 51. Actually, NH2 group is an electron donating group. So if an electron donating group is attached to the ring, then the incoming electrophile has to go to ortho and para position, right? But why meta position product is formed? It is formed around 47%. It means half of the product is formed, right? Half of the product is meta. How? So why meta product is formed at this higher percentage? So that is one reason. That is one reason. So actually NH2 group is an ortho-para directing group. Okay, so only first product and the third product should form. The middle product is formed because of the reason which I am going to tell. Okay, so here in case of nitration, we are using acids, right? acid will contain H plus. Acid will contain H plus. So the nitrogen lone pair will go and attack that H plus and it will produce C6H5 NH3 plus ion. It will produce NH3 plus ion. Nitric acid and sulfuric acid, both of them are highly acidic. Okay, very strong acids. So acid will contain H plus and the lone pair of nitrogen goes and attacks the acidic hydrogen and it is forming NH3 plus. Now NH3 plus containing compound is called as anilinium ion. It is called as anilinium ion. And this NH3 plus is acting as an electron withdrawing group. NH3 plus is an electron withdrawing group. So if an electron withdrawing group is attached to the ring, then the incoming electrophile will go to meta position, right? So that's what we are learning from benzaldehyde lesson and the benzoic acid and all. So if an electron withdrawing group is attached, then the electrophile will go to meta position. And because of this reason only, the meta position is also formed in equal amount with that of ortho and para. Can you guys able to understand this? The statement type questions will be coming, okay, from this type of concepts. So you should know, like why meta is formed at 47%. It is because of the formation of NH3 plus ion. NH3 plus ion is an electron withdrawing group. So the electrophile is going to meta. So you need to know all these things. All right. So I hope it is clear to all of you. Do you guys have any doubt from this nitration part? Do you guys have any doubt from this part? Shall I go for the formation of para-nitroaniline? Guys, why are you all staying so silent today? Shall we go for the next reaction? Yes. Thank you, Bishan. Fine. So in the previous case, all three types of products have formed, right? I don't want all the three products. I want only one product, that is para product. That too 100% para product I need. So what I have to do to get the para product as the major product? The same thing you have to do. The same thing that we have done for bromination, we are going to do here also. Take the aniline, use acetic anhydride and form acetanilide and protect the ortho site. Okay. So now instead of adding the halogenating agent, add the nitrating agent. Add the HNO3 and H2SO4. So this nitrating mixture will produce NO2 plus electrophile, right? So that electrophile will go and attack only the para position and we will get the compound like this, and then on doing hydrolysis, we will form the para nitroaniline. The entire group will be converted to NH2. Okay. So this is the way to form the para product as a major product. Okay. So now let me go for the third electrophilic substitution, which is called as sulfonation. So basically in sulfonation, we use 4, right? So H2SO4 contains H plus ions and HSO4 minus ion, right? It will be dissociated like this. So take the aniline and treat it with H plus. What will happen? The nitrogen lone pair will come and attack the H plus. So we get NH3 plus and along with that HSO4 minus will also come and coordinate with it. And they form a salt. The name of the salt is anilinium hydrogen sulfate. Okay. And this compound is treated with H2SO4 again. Okay. This compound is treated with H2SO4 again. It forms NH2 and SO3H. So sulfonating agent is H2SO4 and the electrophile from sulfonation is SO3H plus, right? SO3H plus. So since this group is a kind of bulky group, the incoming electrophile SO3H plus will go and attack the para position. So we are getting the sulfonylic acid as a product, and this product is in equilibrium with the other compound, okay, which is a Zwitter ion. So how does this ion forms? So the nitrogen lone pair will come and attack this hydrogen, and the bond, the electron which is in front is going towards the oxygen. So that we are getting NH3 plus and SO3 minus, which is called as Zwitter ion. Okay. The name of the compound is not Zwitter ion. Okay. If you are having a positive charge and a negative charge in the same compound like this, then those compounds are called as Zwitter ions. Okay. You will study about this Zwitter ion in the biomolecules lesson of chemistry. And also you will study about this in biology. If you have biology as one of your subject, then in biology also you will study about this Zwitter ion. Okay, it is very easy. If positive and negative charge is present on the same compound, then that compound is called as Zwitter ion. That's all. Okay, it is neutral. Okay, it is neutral in nature. It is amphoteric. So these are the properties of Zwitter ion. So with this, the chemical properties of amines is getting over. Okay, so do you guys have any doubt till this? Do you guys have any doubt till this? Shall I go for the last small topic of this lesson? Shall I go for the last topic of this lesson? Do you guys have any doubt from the preparation and the properties of amines? Okay. So the last topic is diazonium salts. We have already come across with this diazonium salts. Okay. So let me introduce something about this diazonium salt. So we have two types of diazonium salt. One is alkyl diazonium salt, where alkyl group is present with the nitrogen, okay, which are highly unstable. I have already told you when I am discussing the nitrous acid reaction. Alkyl diazonium salts are unstable, okay. And the second type is called as aryl diazonium salt or arene diazonium salt. Arene means aromatic ring containing diazonium salt. So this compound is stable, but only at very low temperature, from 0 to 5 degree, 273 to 278 Kelvin, only it will be stable. Okay. So the reason is why it is stable at this temperature. It has one reason. The reason is due to resonance. The reason is due to resonance. So we have aromatic ring. Okay. This is C6H5N2. We have an aromatic ring. And this N2 group, this N2 is an electron withdrawing group. So it will withdraw the electron from the ring. So the electrons will move towards the nitrogen and it creates the positive charge on the ring. So to neutralize, to help that, the pi electrons, the conjugated pi electrons will come and get resonated over the ring like this. Okay. So they'll get resonated like this. And because of this resonance, the compound is stable. Because of the resonance, the compound is stable at a very low temperature. Okay, this is very important. If somebody asks you that why benzene diazonium chloride is stable at low temperature, means you should be able to say that the reason is due to resonance. Okay, but such kind of resonance is not possible with alkyl, right? For example, if I have CH3, N, triple bond N. Do you think that resonance will happen here in CH3? Obviously, no. So there is no resonance. So the compound is highly unstable. And here, because of resonance, the compound is stable. All right. So this is about the introduction part of this diazonium salt. Now let's go for the method of preparation. There is only one method of preparation. And just now, before few minutes, we have discussed the preparation of diazonium salt also, right? Diazotization. You remember? It is diazotization. So taking aniline and treating it with nitrous acid mixture at low temperature will form benzene diazonium chloride with the removal of NaCl and H2O. This is the same reaction which we have seen. Okay. So there is only one method of preparation for this diazonium salt. So you are going to learn this reaction alone. Okay, the same reaction which we have already studied. There is no separate preparation for diazonium salt. All right. So preparation of diazonium salt is over. Now let's enter into the reactions involving the displacement of nitrogen. Okay. So these are the chemical reactions of diazonium salts. Chemical properties of diazonium salts. So let us go for the first reaction. The name of the first reaction is Sandmeyer reaction. So we have to take benzene diazonium chloride as a reactant and treat it with the Sandmeyer reagent. So here I am going to treat it with the three different types of Sandmeyer reagent. The very first is copper bromide with HBr. So from this, we get bromobenzene and nitrogen. If I use copper chloride salt with HCl, then I will get chlorobenzene. If I use copper cyanide with KCl, then I will get cyanobenzene. Okay. So different types of benzene can be formed from benzene diazonium chloride. Okay. At the same time, from the Sandmeyer reaction, you cannot prepare iodobenzene and fluorobenzene. This method is not used to prepare iodobenzene and fluorobenzene. So Sandmeyer will not work out for the preparation of these two. So we have to use some other reagents. We have to use some other reagents. So these are the Sandmeyer's reagent, but this reagent will not form these two compounds. So we have to go for some other reagent. Okay. So Sandmeyer reaction means copper chloride, copper bromide, and copper cyanide with HCl, HBr, and KCl. This has to come in your mind. Okay. Whatever might be the halogen you are taking, that halogen has to come and get substituted in the ring. That's all. The N2Cl part is getting converted to chlorine, bromine, and cyanide. Okay. So this is Sandmeyer reaction. Then the second is Gattermann reaction. So here we have to take benzene diazonium chloride and treat it with copper in presence of HCl. Okay. Copper in presence of HCl. What is the difference between Sandmeyer reagent and Gattermann reagent? In case of Sandmeyer reagent, we are using copper chloride salt. This is a salt. Okay, with HCl. Copper chloride salt with HCl. But here in Gattermann, we are using copper, metal. Copper is here is a metal. So there salt with HCl and here metal with HCl. This is the only difference you have to keep in mind if you are studying about Sandmeyer and Gattermann. Okay. So since we have HCl here, chlorobenzene will be formed with the removal of N2 and CuCl. And if you use copper in presence of HBr, since because HBr is here, we get a bromobenzene and nitrogen and CuCl. Okay. Is it clear to all of you? So the only difference is the reagent. The other things are same. Clear? This is Sandmeyer Gattermann reaction. In Gattermann reaction. Now let's go for the formation of iodobenzene. So for the formation of iodine substituted benzene, you have to treat the benzene diazonium chloride with Ki. You have to treat it with Ki, potassium iodide. So here we have iodine and that will go and substitute N2Cl with the removal of KCl and N2. KCl will come out. N2 will come out as nitrogen gas. And the remaining iodine will go and substitute in the ring. Okay, which leads to the formation of iodobenzene. Very easy. The fourth reaction is the formation of fluorobenzene. So who is the fluorine giving source? It is HbF4. HbF4. H plus BF4 minus. If you treat the benzene diazonium chloride with HbF4, the Cl minus will be substituted by BF4 minus. Cl minus will be replaced by BF4 minus. The anion, the Cl minus anion is getting substituted by BF4 minus anion. Okay. Then if you heat this, you will get fluorobenzene. Okay, one fluorine is attached to the ring. Remaining we have BF3, right? We have BF3 here and the nitrogen. So BF3 and nitrogen will come out as a byproduct. So this is how we are preparing the fluorobenzene from the benzene diazonium chloride. Okay. So we have prepared chlorobenzene, bromobenzene, cyanobenzene, and here iodobenzene and fluorobenzene. All right. So now let's go for some more reactions. Fifth reaction is the formation of benzene. Here we are going to form benzene. We are not going to form any substituted benzene. I am going to prepare benzene from benzene diazonium chloride. So who are the reagents? The reagents are H3PO2 with H2O. There are two reactions for the formation of benzene and this is the first. H3PO2 is called as hypophosphorus acid. Okay. So this will lead to the formation of benzene with the removal of H3PO3, N2 and HCl. So H3PO2 is getting converted to H3PO3. It means addition of oxygen is happening, right? So this is called as oxidation. This is called as oxidation. So by this oxidation, we are preparing the benzene. Okay. The second reaction is with the use of ethanol. So ethanol on oxidation will produce ethanal, right? What is this? This is ethanal, aldehyde. So ethanol is getting oxidized to ethanal and the benzene is formed as a major product. Nitrogen and HCl are the byproducts. Okay. So by these two reactions, we can prepare the benzene from benzene diazonium chloride. Okay. So now let's go for the sixth reaction. Sixth is the formation of phenol. What is phenol? OH attached to benzene is called as phenol. How to prepare that? Take the benzene diazonium chloride, just add water and heat it. Just add water and heat it. Okay, you will get phenol. You will get phenol. Nitrogen will come out, HCl will come out, and the remaining OH will go and substitute in the ring. Okay, so we get phenol. The very simplest method of preparation is the phenol preparation only, right? So here we did not use any big reagents at all. Just by using water and heating it, we are getting the substituted benzene phenol. Okay, so this is the sixth type of reaction. The seventh is the formation of nitrobenzene. So how to attach the nitro group to the ring? How to replace N2Cl with the nitro group? So take the starting material, treat it with HBF4. So what will happen? As I have already told you, the BF4 minus will go and substitute the Cl minus and we will get this product. Now, what you do? Treat this compound with copper. Treat this compound with copper metal as a catalyst and heat it with the help of NaNO2. So you should keep these reagents in your mind. Okay, we have to memorize the reagent. There is no other way. Okay, so heat the compound with copper metal with the help of NaNO2. So we are having Na plus and NO2 minus, right? So NO2 will go and substitute in the ring and nitrobenzene is formed. So nitrogen gas will come out and the remaining Na will come out with BF4. So we get NaBF4 as one of the byproduct, nitrogen as the another byproduct, and nitrobenzene as the main product. Okay. So these are the 7 reactions of benzene diazonium chloride from which different derivatives of benzene can be prepared. Okay. So any doubt till this for anyone? So we have 2 more reactions. Those are called as coupling reactions. So before that, I just want to ask whether you guys have any doubt till this or not. Just learn the reagents that has to be used. Okay. And the mechanism. That is enough. Very easy. So keep on learning and keep writing so that you will not forget. Okay. Shall I go for the next? Shall I go for this reactions involving retention of diazo group, which is a coupling reaction? Guys, answer me fast. Any doubt? JNV Kokrajar Bishan, tell me, do you have any doubt? JNV Roing, Madhukar. Okay. So here in coupling reaction, we are going to see two reactions, two coupling reaction. The first one is with phenol. Okay. So take the benzene diazonium chloride. Here in the nitro group, the nitrogen part, the diazo part, which is called as N2 plus part, it will retain in the product. In the previous case, the nitrogen N2Cl has been totally converted to Cl, Br, Cn, etc. But here in the coupling reaction, the diazo group will be retained. Let us see how it is getting retained. So take the salt, treat it with phenol. Okay, C6H5OH is called as phenol. And the pH should be maintained between 9 to 10. pH should be maintained between 9 to 10. Okay, and it leads to the formation of para-hydroxyazobenzene. So OH is at the para position, right? Para-hydroxyazobenzene. It is an orange color dye. It is an orange color dye. So it is formed by the removal of this HCl. So remove the HCl, take one of the bond and connect here. You will get this compound. Okay. Orange color dye with the removal of Cl minus and H2O. Okay. So this is the reaction with phenol. So let me do the second coupling reaction with aniline. So what will happen if aniline is used in place of phenol? Take the benzene diazonium chloride, treat it with aniline. C6H5NH2 is aniline. And the pH here should be 4 to 5. Okay, 4 to 5. So here what will happen? The HCl will be removed. Okay, HCl will be removed and connect this. So what will you get? We get the same type of product, but instead of OH, NH2 will come here. Okay, which is called as para-aminoazobenzene, and the color of this compound is yellow. Color of this compound is yellow. Cl minus and H2O are the byproducts. Okay, so an yellow color dye is formed. Okay, alcohol, phenol means orange dye and aniline means yellow dye. So these are the two coupling reactions for this amines. Okay, benzene diazonium chloride, not amine, for benzene diazonium chloride. All right. With this, the entire lesson is getting over. With this, I am finishing the amines lesson. Okay, very small lesson it is. So I hope the diazonium salt part, which I have discussed today, is clear to all of you. Am I right? So I have got few previous year questions also to solve here in today's session, but we don't have time, right? We don't have time. We don't have time. So I will try to do this in the next session or in the weekend class. In the Saturday weekend class, the other teacher will do this. Previous year question. Okay. So do you guys have any doubt from this lesson? You guys have any doubt from this lesson? No doubt? Okay then, take care students. See you all with the next new lesson in the next class. Okay, take care. Bye-bye.